Right, hello everyone. Today we're going to be talking about uniform circular motion. So an object moving in a circle at constant speeds is still accelerating. Understanding why is the foundation of uniform circular motion. So what is uniform circular motion? Uniform circular motion describes the motion of an object traveling in a circular path at constant speed. The key distinction is between speed and velocity. Speed is a scalar that remains constant. However, velocity is a vector because it has both magnitude and direction. Because the direction of motion changes continuously as the object moves around the circle, the velocity is constantly changing. Okay, so if we have a look at this one, you can see the car is constantly going around the circle at the same speed, but it is changing direction. Because it is changing direction, it means that there is a change in velocity. So change in velocity means acceleration is present, even though the object never speeds up or slows down. So centripetal acceleration. The acceleration associated with uniform circular motion is called centripetal acceleration. It always points towards the center of the circle, perpendicular to the velocity at every point. So that's this blue vector here, represents the centripetal acceleration. This one here, and is represented by AC. And we can see it's acting perpendicular to the velocity vector here. Alright, because the acceleration points inwards, while the velocity points gently, the acceleration continuously changes the direction of motion without changing the speed, keeping the object on its circular path. Now the magnitude of the centripetal acceleration is calculated like this. A is equal to velocity squared divided by the radius. Okay, now centripetal force. By Newton's second law, acceleration requires a net force. The net force producing centripetal acceleration is called centripetal force. It also points towards the center of the circle at all times. Okay, so the formula for centripetal force is equal to mv squared over r. Centripetal force is not a new type of force. It is always provided by an existing force in the situation. For a satellite orbiting Earth, gravity provides it. For a car turning a corner, friction provides it. For a ball on a string, the tension provides it. Okay, now period and frequency. The period is the time taken for one complete revolution. The frequency is the number of revolutions per second. So they are related by t, the period, equals 1 over f. The speed of the object can also be expressed in terms of the period and radius. So you can also have v is equal to 2 pi r over t. Okay, so to summarize, uniform circular motion involves constant speed but continuously changing velocity direction, meaning that centripetal acceleration is always present. This acceleration and the centripetal force producing it always points towards the center of the circle. Centripetal acceleration is given by A equals v squared over r, and the centripetal force is equal to mv squared over r. The force is always provided by an existing force rather than coming out of nowhere, and it is always mentioned in the context of the problem. Follow for daily QCAA content.